Today we're going to learn how to tram the tool head on a vertical milling machine. Why do we tram the tool head? Well, tramming is essential in order to ensure squareness of the spindle to the table or the work holding device on the mill. If we're looking for an accurate setup, we have to double check this before we start using the machine for the day. You never know what the previous operator may have adjusted or could have possibly had a crash and knocked the machine out of tram and not even known it. You might ask, why does the machine move in all these different directions? If they just welded that thing completely square to the top of the table, we wouldn't need to do this every time. Well, oftentimes we're actually doing vise work, and if there's any kind of high spot or dirt or oil between the vise and the table, it's going to be out slightly, and sometimes the table will actually get worn. It'll become a dish. So the issue there is we have to be able to adjust our machine to compensate for this wear or for these nicks or high spots. So it's really important to be able to have that versatility. Some machines only have one direction of movement on the head. Most, like a Bridgeport, will have both directions able to move. But one where there's only one direction or no direction where we can tram are actually more difficult to use, in that you'd have to use shims if you wanted to achieve a certain level of accuracy. The tools you will require will be a 3/4 inch wrench. We ask that you use the box end of the wrench to prevent any rounding of the bolts and nuts that attach the heads to the machines. A needle type dial indicator, a dial test indicator, typically one with about 30 thousandths of travel is sufficient. A drill chuck or collet, or an indicator holder, depending upon how your indicator is set up or what you have. The indicator we're showing you today has an integral shank. It's an inner rapid, so I used a drill chuck. One reason is that they don't make a collet standard for one of these inner rapid shanks. But if you have one with a more standard size shank, you could just use the regular R8 style collets available with the machine. Or if you have an indicator holder that clips on the outside of the spindle, that's fine as well. What I'm looking to teach you here is purely the procedure to tram the machine. The preparation is absolutely crucial. If you don't prepare the machine well for service for the day, you will not make accurate parts. You very well hit a tolerance once in a while by dumb luck, but most of the time, if you are not preparing your machine properly, you're asking to have scrapped parts and a frustrating day. So the first step of the day is going to be stoning the table and the bottom of the work holding device. Say we were putting a vise onto this table, I would stone both surfaces and feel for high spots. You have to stone those high spots all the way down flat, and then wipe it with a nice clean rag to ensure that there's no oil, stone pieces, chips that would otherwise be measurable. Remember, anything such as a high spot, oil, dirt, etc., that is between your workpiece and that table is going to decrease your accuracy. Now we're going to attach the indicator to the spindle. If you're using a drill chuck or an R8 spring style collet, ensure that both mating parts are absolutely cleanly. We cannot be putting a collet or a drill chuck with chips on it into the spindle. It will damage the spindle and it will make your indicator run out slightly. So be sure to take a rag, obviously with the spindle off, and wipe inside the spindle and check for any high spots. If there are high spots in there from someone else closing chips in it before, come get myself, Mr. Schwartz, and we will help you stone those high spots out of that spindle. Once that's clean, you're going to place your collet or drill chuck into the drawbar, or into the spindle, and you're going to hand tighten the drawbar. Once it's snug, you're going to hold the brake on the machine, and you're going to tighten it lightly. Please do not over tighten the drawbars. You do not need much torque to properly lock the tooling in place. If you over tighten it, you will break the drawbar. If you're using an external type indicator holder, such as an Indicol, go ahead and just attach it to the outside of the spindle, and you don't need to worry about any of that. At this point, lock the quill down against the micrometer nuts and put your spindle into neutral. What I always recommend is to check the left to right perpendicularity of the tool head first. It's much easier because you can see both sides very clearly. If you notice, the back reading is kind of behind the spindle, so you're going to have to crane your head around there and duck underneath the ram in order to see what the reading is. That can be a little trying at times, so typically getting your first two sides good where you can see them is much easier. So go ahead. If you suspect this head is very out, say you just had the machine in storage, the head was upside down, I wouldn't even start with the indicator touching the table. I would move the table very close to my needle, and I would rotate it back and forth and see what the light gap looks like. If this is a machine that's currently in service, or you haven't had the head off of zero, you can most likely come right up to the table and put about 5/1000 load on this needle at this point. Go ahead and spin the bezel of the indicator to 0 so that we know we have a 0 reference point. We haven't actually adjusted anything in the machine at this point, but we're going to call this 0 for right now to see how far out we are on the other side. How are we going to do that? Well, go ahead and rotate the indicator 180 degrees. Be very conscientious of not allowing the indicator needle to get caught on the table cracks. Those T-slots can really do a number on an indicator if there's too much preload on them. So at this point, we're going to note the difference between the first and the second reading. We started on the left, we went over to the right. If you'll see in the lower right corner that picture, we're out 10/1000 off of that original 0 that we arbitrarily created. So if we're out 10/1000 left to right, we're going to have to adjust our head 5/1000 on one side so that it's on a 0 plane. That's the key to tramming. Oftentimes people make the mistake of they say, oh, it's at 10, I want it at 0, and they then crank it to 0 on the right side. Well, what that's going to do is you're going to just end up making your head unsquare in the entirely opposite direction. So how do we adjust this axis? We go ahead and we take the box end of our wrench and we loosen the 4 bolts that are facing us on that tool head. Please do not loosen those too much. If you loosen those too much, that's all that holds that head in place. Luckily, they thought it through and gave this studs, so you're actually loosening a large nut. But if you loosen it way too much, you're going to have the head bobble around some, and you're going to get some erroneous readings. Also, it's kind of hard on your indicator because it can make the head really drop. So don't loosen those too much. You're going to loosen them maybe a half turn just till you don't feel any pressure on those. On the same token, however, we will never ever try to turn the adjusting screw, which is located on the right hand side of the head just above the quill feed handle. We would never adjust that with these 4 bolts tightened. If we do, it's going to cause a large problem for us in that it actually will break that shaft, and we have to remove the head of the machine and drill out the old shaft out of a worm gear. It's a full day's job to replace that. So please be sure that your head is loose when you go to adjust it, just not too loose. Okay? So we're going to adjust our indicator half the distance. Just remember, if you want to raise the spindle or put less pressure on the indicator on the left-hand side of the machine, you're going to turn that screw counterclockwise. If you're going to raise the spindle on the right-hand side of the machine, you're going to turn the screw clockwise. Oftentimes, you're just going to push or pull on it and see which way the indicator goes and move accordingly. It's not that essential that you memorize which direction it moves. Now we're going to verify that by moving half the distance, we've actually corrected the problem we had. So we're going to gently snug those bolts that we loosened before. We're going to rotate 180 degrees back to the starting point. Say we moved to the 5,000th, say we moved from 10 up to 5. Now we're going to rotate the spindle 180 degrees, and it should read 5 as well. If it doesn't, we're going to have to continue to adjust. Oftentimes, the theory that I'm describing right now is a mathematical perfect world type scenario where we are out 10, we move half that distance, we're on this new theoretical plane. Well, there's a lot that goes into this. Your table could be slightly dished. There could be a lot of different variations going into why it didn't just go right in. So oftentimes you're going to have to go back and forth multiple times, but you shouldn't have to do it all day unless this is your first time tramming a mill. Then it's probably going to take you all day. But once you've gotten the hang of it, it'll take several rotations of adjustment to get it perfect. Now what we're going to do is we're going to see how out the tool head is and why. So we have our left to right absolutely perfect. Left to right, we're right at 0 when we move 180 degrees. Now, I'm not going to move the bezel on this indicator. I'm going to just turn my spindle 90 degrees so it's pointing directly at me. And I'm going to see my deviation from those 2 points. The really unique part here is if we think about it geometry-wise, if we have it perfect left to right, and we bring it up to and we make it 0 at the front, the back should follow suit within a few thousandths. So what we're going to do at this point is we're going to adjust our we're going to rotate our spindle up front. We're going to loosen the 3 bolts on the side of the knuckle, and we are going to adjust the head front to back until the indicator reads 0, just as the side does. When adjusting, remember that to raise the spindle, on the back side of the machine, we're going to be turning the screw counterclockwise. To raise the spindle on the front, we're going to turn the screw clockwise. Again, as I said on the other one, does it actually matter to memorize this information? No. What you're going to do is you're going to know you have to go a certain direction, and you're going to pull on the wrench or push on the wrench the direction you want to go. Once you get used to it, you'll remember which direction it goes. So as I said though, if we have it zeroed on either side and we move it up towards us and we zero it to the sides, the back should indeed read 0 too. So now we're going to snug those 3 bolts slightly that we're holding the knuckle, and we're going to ensure that our tram job front to back both are reading 0. Then we're going to secure those bolts a little more if it is indeed okay. And now we're going to verify that our job is complete. We're going to rotate the indicator a full 360 degrees, and we're going to see that it reads 0 in every quadrant. Once you're satisfied that your head is tram enough for whatever job you're doing, you can then go ahead and secure the 4 front bolts as well as the 3 side bolts. We don't use torque wrenches in here, but it's about 50 foot-pounds. It's not tons of torque. If you over torque the fronts too much, you can actually egg shape the casting and make the spindle difficult to move up and down. And you can break or strip off these bolts. So please, we ask that you just snug them well to get the proper preload on the bolt, but we don't want over tightening because that can lead to many problems down the road with these machines. Now we're going to remove the indicator and take care when you go to tap, if you're using a collet, when you tap on the drawbar, your indicator is going to drop out of that collet. So make sure you're holding on to it very well, because any kind of shock to that jeweled movement can create inaccuracies. So it's early on in the year. It's difficult to make these adjustments with a broken indicator when we're only a week in. So in review, what direction do we check first? Typically, I recommend doing left to right. You could technically start front to back, but I find it much easier to see the left to right adjustments. How much would you move ahead when you've moved it to the opposite side of the table and you see the deviation? You are going to move it half of what it deviated when you, whatever your deviation is from your first 0, you're going to move the head half that amount, not the full amount. When checking the y-axis, do both front and back have to be zeroed? In theory, no. If you have the 2 sides completely zeroed and you move and you adjust the head in on one point, the final 4th point of our tramming should fall into line without too much adjustment. Sometimes it does take a little tiny bit of adjusting after that. Does it make a difference if the area checked is bigger or smaller? Say we use an indicator and we only have the needle pointing out versus having like a 3 or 4 inch swing. The larger the indicator swing, the more accurate your tramming job will be. So obviously there's a limit to how far out we can swing this indicator, but just know that if you're doing an extremely precise job, you're going to have to use a larger swing on your indicator to ensure accuracy. And when the spindle is moved up with an adjusting screw, does it add or reduce pressure on the indicator? Whenever we move our spindle up with an adjusting screw, it's going to reduce pressure on the indicator. So different indicators read differently, and you're going to have to get used to how yours reads, whether it adjusts, whether it auto reverses, or if it's a single direction. So a lot of this just comes in time, so you just have to practice adjusting. Have any questions or concerns, please feel free to ask me in the shop, and we will get whatever problems you have straightened out. Thank you for your time, and have a great day.